I'm James.
Hi, James.
Hi, everyone. I'm James.
Hi, James.
It's a pleasure to be here today. This is my very first SciPy talk. I start all my talks in just about the same way. So because this gets recorded and I like to remember where I was, it is Friday, July 15, 2016. We're at SciPy 2016 in Austin, Texas. This talk is called Hacking the CPython Interpreter. We had some video issues getting everything set up, so hopefully those won't occur during the talk, but if they do, please bear with me. I should have like a big picture of a bear in my slide deck just to make that joke. So let me tell you, the way that I created the proposal for this talk was I took things which I had talked about in previous presentations, and I cut and paste them into one big talk, because I thought if they won't accept one of my talks, they'll accept 5 of my talks crammed together into one. Then they gave me a 30-minute talk slot, so I had to see what I could do within those constraints. What I will tell you is that this talk is not about how easy it is to understand and hack the CPython interpreter. I have, in fact, given a talk like that before. I gave a talk at PyData in Dallas last year called CPython Meanderings, where, and this is a completely unprepared talk, I showed you just how I got into CPython hacking and some approaches that you can use without having to really do any prep work. Just some simple approaches you can use to understand what's going on in the CPython interpreter. Additionally, if you're interested in this material, you can just email me. I'm more than happy to talk to you about things that can be done in the CPython interpreter. A couple of people have actually come up to me at this event and in previous events with some ideas, and I gave them, to the best of my abilities, my thought process for how hard or how easy it would be to do that. Now, one thing that you can notice, and one thing that's going to be very important in this talk is, check out my email address. I am on Twitter, don't use this code. My email address is james@don'tusethiscode.com. I have a blog which I haven't updated in many years at seriously.don'tusethiscode.com. That may be an important theme later. This talk, however, is about when you should hack the CPython interpreter and some qualifications around how you should hack it. Not technical qualifications, but qualifications around maybe the process of when it's appropriate or when it isn't appropriate. So in order to actually show you what I mean, I want to show you a couple of demos. I want to show you a couple of things that I've done that I've presented at different conferences. Now, one problem that I have is procrastination. What that means is I don't prepare my talks until the last minute. Even when I have time to prepare the talks ahead of time, inspiration doesn't strike me until I get back to a hotel room at like 10, and then I watch like an episode of Babylon 5, and it's like 11, and then by 11:30, I'm like, okay, I'm really getting close to something, and then I check to see if there's any new episodes of any other number of television shows. So I get caught up on my Game of Thrones, and then by about 1 or 2 a.m., I'm like, okay, I need to put something together. And so in about the 3 to 4 hours up until when I have to be at the event, I put a talk together. So most of these aren't exactly polished, but they give you an idea of some things that you can do. So let me show you the very first one. Now this is actually one of my favorite things that I've done in the CPython interpreter. It's called the bang bang, and it's named after the syntax that I added. I made a small addition to the CPython interpreter where you can have 2 exclamation points and you can lift the evaluation of some statement higher in the evaluation of a module. And I'll show you what that means. So let me show you a couple of things that people kind of complain about in Python. Now let me also change is that better? Okay. So some people complain that if I do something like this in Python, let's just do some computation. This isn't optimized. And we can tell that it's not optimized because if we disassemble this, you can see every single time in that loop it's computing the length of ABC, but ABC is a constant, and why can't Python just go and see that the length of ABC will never change? Well, the reason for that is, unknown to you in some other part of the program, maybe in some other thread, somebody might have monkey patch the len function, and so in each iteration of that loop, you might not be able to guarantee that it's always going to return the result of 3. However, that's something that the computer couldn't automatically do. But a human being could easily look at their code base and say, well, hold on, we're not crazy enough to monkey patch len. This is always going to be the value 3. Another thing that kind of gets people upset is there's a lack of richer custom literals in Python. And so in cases where we wish we had custom literals, like for date time, we don't. And as a result, something like this is erroneous. Right? There's a bug in my program, and I should know there's a bug in my program. There's no 31st of February, and yet until I run that function, I don't actually see that bug. Now, one thing that we sometimes do is we say, okay, we could just lift these variables up to module scope, so we could have constants at module scope. And so when the module is imported, we get an error. And module import time is our equivalent of compile time in Python, in my opinion. Except that ends up cluttering up your module level scope. You have a bunch of constants up there that are only used in one area. It turns out in Python, we have this conflation of scope in the sense of this variable can be accessed in this lexical environment and evaluation context. So what I did was I went into CPython and I added an exclamation point operator. And what it does is it lifts the evaluation of some expression to either one higher scope or to module level scope. So I'll show you how that works. I just put an exclamation point in front of this. And now this variable is no longer evaluated when the function is run. It's evaluated when the module, or rather one scope higher, in this case, when the function is created. So for example, if I do something like this, and I'll return len of ABC, right? And I'll return G. You can see this is very far deep down. There's no way for CPython to go into that and say that's a constant expression. If I were to do this again, but put a double exclamation point in front of this expression, this will be evaluated at module level. And hopefully, live demos are always scary. If I disassemble A called F like that, create an A, you can see from the disassembly that it actually went in and it evaluated that. And interestingly enough, this works very nicely. So if that were an expression like ABC plus something else, and that something else was a variable that was introduced in a closure, it would wait to evaluate until it had all the variables. It's a very simple, very easy thing to do. I added a piece of bytecode, and when you create a function, it will, when you're in an evaluation scope in your ceval loop, you'll see if you have, you'll go recursively look into all the code objects that you have until you find one of these bytecodes. And when you find that bytecode, if you have enough information to evaluate that, you'll evaluate it ahead of time and replace the coconsts of the code object, or whatever the expression is, with the actual constant value itself. I really like this. I think it's a really neat idea. Nobody cared when I showed it to them. And every time I show this to people, people are like, who cares? That's the truth. So I'll show you demo number 2, which I thought maybe this would be more appealing to maybe a data science environment. I call it AST expressions. So Matt Rockland came to me and he said, you know, it's really a pain when I'm using things like numexpr because I have to give the expressions I want in strings, and that's just a pain in the butt. And in other languages, I have the ability to express ASTs directly. So I added that to Python with a $sign operator. So here, this is no longer the actual evaluation of x plus y. It's an AST expression that represents x being added to y. And I can add it to a constant, and I can bind y and x. Whoops. And I can actually evaluate the value is. And I can do some neat things with this because, for example, import add and trueDiv. I could do something like this. X plus y, z plus 2 times w. Actually, I'll do this, like that. And I can then bind w equals something and y equals something, and then figure out the value. So I could build, oh, there's an unknown value in here, probably another w. Oh, the unknown value is the z. So there we go, and I can evaluate it. And I can even do really neat kind of Lispy stuff like this, e equals f of xy divided by f of yx. I could bind x and y, but leave the function itself unbound. Let's call that e2. And then I could bind the function separately. So that's what happens when you take a function and divide it by its operators reversed, like that. And you can see you could do some neat stuff, build syntax trees very easily. It's a very simple, very easy syntax. You might even be able to take libraries like SciPy and kind of turn them inside out, because you can see SciPy has a lot of mechanics for creating these symbol objects. Of course, SciPy does many more things than that. We actually have 2 SciPy core developers in the audience, so I don't want to say that SciPy is merely just tricks like this. But there's a lot more to it, but you could see this could really help in creating a vast number of libraries where you are essentially building expressions. Of course, when I showed that to people, nobody really cared. There was a thread that we created with a lot of people who were interested in adding macros to Python. That thread went nowhere. And so, unfortunately, that feature, you're never going to see that in mainline Python. I'm going to show you the last feature, and this was me just trying to be provocative and to show the audience something that would really shock and appall them. It's called rwatch. So this one I actually created the first iteration of. What should really appall you is I don't use virtual environments. I created my own virtual environment called withdir. Oh, I'll give a talk about that someday. Anyway, here's my Python interpreter. It's a Python 3.5. One thing that nobody asked me about was why the last two examples were in Python 3.4. There's two reasons for that. Number one, there's not enough user interest to actually keep these things updated. And the second reason I'll get to very shortly. Let me show you readwatch. I have a Python interpreter. I import rwatch. And what that does is it adds two things to my sys module. Get rwatch and set rwatch. Get rwatch just tells me what my readwatches are. Set rwatch just sets readwatches. If you're a C programmer, you're familiar with readwatches and tools like GDB. What that means is every time a variable is accessed, you have the ability to perform some callback action. So I added this to Python, and it mostly works, and I'll show you an example of it. Here's my callback. It takes a frame and an object, and it'll just print, I saw some object at some frame, object in the frame, and I'll return the object, and I'll just set a readwatch with the ID of this object and my function. And then every time I try and access this x variable, you can see it calls my callback. And so you can see if I pass this x variable into a function, the callback got called twice, once going in and once when it's looked at inside the function. That could actually be very useful for debugging. And one thing that I've tried to get people excited about for this is that you could build a really nice debugger with this, and you could debug these really complex data pipelines where maybe there's one data item that's getting stuck along the way, but you don't know where it's being accessed, you don't know where it's being used. I want to show you the really provocative thing that you could do with this, because when I wrote this, I thought, let's be as Pythonic as possible. So rwatch takes not a dictionary, it takes any mapping, so I can pass it a default dict. So I could set a rwatch on every variable in the program. So let me show you what happens when I do this. Object int. And notice it returns something. So what if I just did that? So now everything gets set. So this is what really weirds people out. So now in my Python interpreter, 1 is equal to 2, 2 is equal to 4, 4 is equal to 8. If I say x equals 2, x plus x, can anyone guess what that's going to be? 16. So you can see this was really intended just to provoke people. Unfortunately, when I showed it to people, it was kind of a cute lightning talk, but nobody really said, oh, I really want to put that into production. And I want to talk to, well, not exactly this, but the idea behind it. You get what I mean. I think for some of you who are thinking of changing jobs, that might be one last gift that you might leave your former company. So you might really want to push to put that into production. So I've shown these kind of things at a lot of different conferences. Some of the core Python developers, I am not a core Python developer, but I speak with them whenever I see them at conferences. Some of them have said these are cute party tricks. I have one where I embed a Python 1 interpreter into a Python 2 interpreter into a Python 3 interpreter, and that really was supposed to be a party trick. The question is, are these just party tricks? I don't think so. I think these are a little bit more. I think there are some good ideas behind this. But before we could actually use this for anything, we must ask ourselves the question of, should I do this? No. And there's many reasons why you shouldn't do it. Here's a couple. It looks impossibly hard, and it may be very difficult to do this. You might not care enough about code to do this. In fact, some of you don't care enough about code to even write your own libraries. I'll tell you, I'm one of those people. No, you'd be stuck on CPython. You couldn't use other interpreter implementations. You couldn't use PyPy. You might not be confident enough that if you did something as wild as this, you could do it safely. You wouldn't run into some weird corner case that you couldn't predict. This is very non-standard, and if you were to introduce code like this or any one of these patches into an organization, it would require an enormous amount of maintenance, especially if you had a CPython fork, and a lot of documentation, because you'd have programmers who learned actual Python, now having to use your special fork distribution of Python. Additionally, for some of you, there's no guarantee you could even run a custom CPython in production. Some of you have deployment setups where you can't just arbitrarily say, okay, build this Python from source and run it in production. Additionally, some of you may be very concerned that none of these changes could ever be upstreamed. You could add some really neat features to your own Python interpreter, but you'd never be able to upstream them, so you'd always have to maintain your own separate fork. I want to talk about each one of these issues in the time I have remaining, which is not a lot, and tell you a couple of opinions I have about these. Number one, you don't care enough about the code. I don't think there's any debate here. Some of you really just don't care about the code enough to do something as wacky as this. And I'll tell you this, I don't. So all of the things that I show in all of my presentations are an example of what you can do. I find them interesting. I find them exciting. But in my work as a consultant, helping companies build analytics tools, I don't do any of this. Because you can think, I'm working on fairly small teams smaller than 10. I want to write as little code as possible. And the more sophisticated of an approach I need to employ to get business value, the worse of an experience and the more risk I'm going to take with my client. So I don't do any of this stuff for real work because it would be an enormous amount of risk, and it would be like, it's an unnecessary amount of technical sophistication to solve the kind of problems I want to solve. That said, there are organizations in the world that do care a lot about code. They care enough to pay people to maintain their own internal libraries. In fact, there are organizations that care enough about code to maintain their own forked CPython installations. There are rumors that Google has a couple of different forks of CPython, that Dropbox has a fork of CPython, some other organizations have forks of CPython. Many of you don't care enough about code to even do something as simple as building your own library, and I think that's a reasonable complaint. That said, oftentimes the code is not your deliverable. So in the last example for RWatch, that's more of a debugging tool. I find that sometimes what I'm delivering to somebody isn't the code, it's a result of the code. And so all of the concerns about maintenance or the wackiness of this or technical sophistication, it doesn't matter. If I were to package these up into a CPython that was only used for debugging purposes, I might be able to debug my code better, but I wouldn't ever actually deploy that to production. So a lot of the concerns about this kind of wackiness go away. This is impossibly hard. Now, one thing that I'll tell you is that these packs are actually very easy. If you look at any of my presentations or you email me, I'll tell you how to get into CPython hacking. It's remarkably easy. CPython is a great target for playing around with the Python language, much better than some of the alternative implementations, just because it is a very transparent and easily and well-written library. I want to show you the diffs for these. These are the diffs for bang bang and AST expression. You can see it's about 300 lines of change, 400 lines of changes. I did them in about 3 to 6 hours each. A lot of these changes are, this is plus the context as well. So you can see this is adding in context. It's a bunch of one-line changes and a bunch of targeted places. They actually were not that hard to do. So I'll tell you that in many cases, these kind of changes are remarkably easy. You just need to know where to start. And in order to figure out how to implement something and know where to start, you can talk to people at conferences like this, at conferences like PyCon or PyData. There are a lot of people who at least know the starting point for these. The next complaint, you can't use other interpreter implementations. That's true. There is almost no chance that if you were to get one of these features into a CPython, you could fork a CPython and a PyPy and an IronPython and all of those. You probably don't have the operational capacity to do a change like this across different implementations of the interpreter. That said, you, the PyData/SciPy crowd, probably don't use anything but CPython. Does anyone in this room use PyPy, IronPython, Jython, anything else? One person, do you use PyPy? Okay, we have 2 people in the room, 2 or 3 people in the room who use PyPy. Yeah, every once in a while. And the reason for that is you probably have some reliance on binding some library. You have a really strong reliance on the C bindings. You have a reliance on libraries more than just NumPy that may not be available in the other interpreters or may not be up to date. You may have a dependence on Python 3, where Python 3 support is still lagging in the other interpreters. And in many cases, you may find that for your work, tools like Numba are a better approach than tools like PyPy. You may not be confident enough that you can do any of this safely. And I'll tell you, it's very reasonable to be afraid that you might not know enough to do something like this. I would say that this fear of complications is misplaced, because what I have found is that when you need to solve a problem and you need to add some technical machinery to solve that problem, you're either going to do it at a very low level, maybe adding it to the language or adding some core library, or you're going to put it into your framework. Those complications can exist anywhere in your stack, and you may really want to consider whether you're smart enough to write the frameworks that you're writing, whether those are narrowing your ability to actually deliver code and just kind of, how do I say this politely, piling something on top of something on top of something, just kind of building up and in. So that you might not be able to do CPython hacking effectively, well, you might not be writing your frameworks well enough. I would say use difficulty as a guide here, and you can see the difficulty of these 3 hacks is actually fairly low. The last one I put together, RWatch, I put together as a first draft. in the span between deciding I wanted to do a lightning talk and when I had to get on stage at PyTexas about 1.5 years ago. So in about 30 minutes, I put together the first one. They're very easy to do if you know where to start. And I'm not a core Python developer. I'm subscribed to Python Dev, but I just delete the emails when they come into my inbox. I'm not a hardcore guy. You just play around a little bit, and it actually turns out that CPython is very easy to hack on. This is non-standard. It requires maintenance documentation. No doubt. But I think this is an inevitability with any framework or platform code. And it can't be upstreamed. So these are the two things that I think are most important, that this work can't be upstreamed and that you might not be able to deploy it to production. It is absolutely true that the prep process is slow, it's political, it's contentious, and it can be unpredictable. And we have instances in recent past where we can see things like TCO that people fought for tooth and nail, didn't go anywhere. And it took a long time for a decision to be made, and the decision was not a decision that people agreed with. And at the same time, things like matrix multiplication didn't take that long to get in, didn't take that long to build consensus. It's very unpredictable what will and what will not get consensus. The various macro proposals have received, I'd say, a range of responses from the core Python developers and from Guido himself. And I've seen threads where people said, you know, if we really want to get a feature like this into Python, we have to pitch it in this particular way in order to get people to agree to it. It is very difficult to get all of this stuff into core Python, to upstream it. However, at the same time, there are a lot of core changes to Python that have been introduced without a lot of fuss. Some actually fairly significant changes. Argument clinic is one which significantly changed parts of the CPython interpreter, and that was added without a lot of fuss. A lot of you aren't familiar with this because, you know, the work is not out in the open. It's not a feature-related change, but it has created a lot of churn and code in CPython. Another example might be the CPython startup stuff. If you look and see what Nick Coughlin is trying to do, changing your simple PyRun, simple string flags, and adding all different hooks into different levels of startup, it is a very wide-changing change, a very large change that has the ability to affect many different users of Python where they're embedding Python into other processes. But another question is, you might not even be able to run this in production. You might not be able to deliver this to users because you have to tell somebody, well, download my piece of software and also run a custom Python, which is not something that you could easily do. Well, it turns out all of these hacks can be hot loaded into CPython, and I want to show you how. So when I started doing this, I thought, it's not really useful if I have to tell you to download your own CPython. So I wrote this really simple thing called Lib Hook. And what Lib Hook does is it finds the publicly visible symbols in Python. It adds a little assembly trampoline so you can trampoline into yours. And so all of the 3 ones that I showed you can be pip installed. So you can take a totally unmodified Python interpreter and you can pip install. And when you import that rwatch module, what it's doing is it's actually patching your ceval function to use the one that I want to use. It requires a lot of maintenance because you have to maintain parallel code bases and you have to have code bases for the specific change, for each Python version where there's a change in the ceval loop. It's not a great technique. I did see on GitHub very recently somebody who had formalized a technique like this. My library is very, very simple. It only works on Linux and OS X. There's a mechanism on Windows called detours that I'm not familiar with that's supposed to do something similar. Interestingly enough, on Linux, with the proc file system, you don't actually need to worry about memory protection. My version deals with unprotecting memory pages because you can't just go into a code page and overwrite it with assembly instructions. It turns out you can in Linux because the proc file system does not care about read-write permissions at all. You can just write through proc self-mem and change anything in memory, read anything in memory that you want. You see there's a read-write flag there? Yeah, you can just do anything you want. All your memory page stuff with the proc file system goes out the window. Of course, this adds enormous maintenance burden. But I want to show you, I want to give you one thought. Even though it's an enormous maintenance burden, think if you were in the PEP process trying to get a feature into Python, and you already had 10,000 users who are pip installing it and already using it, think how much easier it might be to get features into Python when you had users already using it. You might have to endure some period of time when it's a little janky and some users on Windows couldn't employ your feature, but it would help in making a case for this is a valuable feature of Python. Additionally, and this is very important, there is a PEP, part of the pigeon process, for adding custom evaluators to Python. I urge you to look at this PEP. I don't know what the official link of it is because it's not on the GitHub page anymore, but what it does is you add to your PyInterpreter state a custom ceval loop, which would allow you to do any one of these changes. package them as a normal pip installable module without any crazy assembly hacks in a robust, controllable fashion, and the only limitation would be grammar changes. You could change the evaluator. You could add extra bytecodes. You could change what happens when bytecodes are evaluated. The Pigeon people want this so that they could do jitting on bytecodes. But you can see you can employ this to whatever degree you want to add interpreter changes. That said, if you want to have grammar changes as well, there are some projects like quasi-quotes and code transformer that will be presented at PyGotham this weekend, which allow you to do grammar changes in the language by just doing, they have different mechanisms for reading the source code and transforming it into Python that works. So, this is the end, and I have a question for you. Should I hack the CPython interpreter? I made a very good case. The answer is no. Didn't you pay attention? Don't use this code. Thank you very much. I'm James.
I think we have time for a couple questions.
So this is a comment that I won't even bother trying to put in the form of a question.
OK, go ahead.
But it seems like all of the things here are features that we could have in Conch if we wanted them.
This is the shell that nobody uses?
This is the shell that no one
Okay.
uses. That's correct. So don't use that code.
Yeah,
either,
exactly.
Yeah. But in particular, the AST one is something that we're actually looking at pretty seriously. So, if you don't want to hack the CPython interpreter, you can come and hack just an alternative CPython implementation. So.
OK, very good.
One more question. Anyone?
Just a quick comment. Seeing now that there's a Python package I could pip install that could mess with my memory pages is going to make me think twice every time I pip install anything.
Oh, you absolutely should. You absolutely should. And code signing won't help you here if you're installing my code. Oh, it's signed. I'll sign it like you wouldn't believe. You still need to read the source. You still need to read the source, is all I'm saying.
All right, let's thank our speaker again.
Thank you.